Hydrogen. It's like Magic the Gathering cards. It comes in a bunch of different colors, and which one is your favorite tells a lot about you. When you start diving into what climate solutions there are out there, it's not long until you start hearing about hydrogen as a potential way to store and deliver energy. But here's the issue. What we need for energy purposes is molecular hydrogen, without any other baggage, just two atoms of hydrogen together. But instead, hydrogen loves bonding with everything it finds around itself. So on Earth, you'll mostly find it inside of other molecules. It's in our cells, it's in trees, it's in petroleum, it's also in water. Two atoms of hydrogen, one atom of oxygen. You know the formula. So if we want to use hydrogen, we have to extract it from somewhere, and to make it easier to track, we give colors to the different extraction processes as a function of how much they pollute. At the bottom of the ladder, you have black and brown hydrogen, which is hydrogen obtained from burning coal. Now, coal does contain hydrogen, but it's mostly carbon. So in order to obtain a small amount of hydrogen, you end up with a bunch of CO2 in your hands as a byproduct, and it's about as nasty as you can imagine. Slightly less polluting, but still made from fossil fuels, is gray hydrogen. It's made from natural gas, which is mostly methane, CH4, reacting with water. What you get out of this reaction is something called syngas, a mix of carbon monoxide and hydrogen. CO2 is still a major byproduct. Currently, it's also how most of the world's hydrogen is made. Then we have blue hydrogen. Blue hydrogen is basically the same thing as gray hydrogen, but on top of it, we have something called carbon capture and storage, CCS, to try and prevent CO2 from actually escaping into the atmosphere. Now, according to the oil and gas companies, it works great. According to everyone else, it's a bit of a band-aid solution at best. But you know what's not a fossil fuel and has a bunch of hydrogen in it? Water. And we've known since the 1700s that basically if you just zap it with a bit of electricity, you get to separate the hydrogen from the oxygen in a chemical reaction we call electrolysis. So using water as the clean input, the question then becomes, where does the electricity come from? If we use renewable energy as a source of electricity like wind and solar, we get green hydrogen, a near zero carbon solution. If it's nuclear energy, we call that pink hydrogen. And sometimes people like to specify yellow hydrogen if only solar electricity is used. But it's a bit less common. Okay, we're done. Oh wait, almost. There is some hydrogen that exists on Earth naturally as H2 and that we could technically directly extract, and that's what we call white hydrogen. However, it exists way too deep in the Earth's crust for us to actually extract it at this point, but in the future, who knows? Now, of course, the reality of the hydrogen economy is much more nuanced than that, and it's not as simple as just hooking up a wind turbine to an electrolyzer and calling it a day. But having this color coding is a useful way to think about these processes. And now, the next time that you read about a climate solution that talks about using hydrogen, take a bit of time to investigate which color of hydrogen it is, so you'll know if you need to blacklist it or give it the green light. Also, I just want to make this clear. The colors are metaphorical. Hydrogen gas is colorless regardless of how you make it, okay? There's no big cloud of brown or green or pink hydrogen out there. It's all colorless, okay? Got it? Okay, just want to make sure. Thank you. See ya. Follow for more.